Okay, swimming in Tcl', just a strange word. You will receive some information about that. At first, I would like to thank you for having the opportunity to give some slides about our work with Tcl' in this special aerospace topic. Just an overview. I will start with an introduction, then a short provocation, just to focus attention, motivation, challenge, solution, and from the point, the outlook. So the introduction, it's about future commercial space traffic, and you can see what we assume, or what the community assumes about that it will in future return as a hypersonic glider. And what does this mean if there is an accident, if there is a fatal breakup, comparable to the Columbia accident in 2003? What does this mean? And it means that debris is raining down to the normal air traffic. And for the Columbia accident, further analysis have proved that the probability that that a normal aircraft was hit was about 0.3, 30%. So it was just luck that nothing more happened during this incident. So the provocation about this topic is that often we are confronted with statements that integration of commercial space traffic in normal air traffic. Why? Because it's only a few movements per year, and it's a topic, something for research or super millionaires for entertainment or for passenger transport. So there is no need. If this really relevant, no, or when, in the very far future. Really, is it really the case? And just for the provocation, look at this here. 10 years between these two small devices, 128 megabyte and 128 gigabyte. 10 years between. And so, look at this. Now we have these commercial, private-based spacecrafts, and who knows when. I have to admit, this comparison lacks a little bit, but that's why I called it a provocation. So what is SWIM? SWIM is the abbreviation for System-Wide Information Management. And it builds, you can regard it as the future intranet for air traffic management. And it requests that all future participating systems have to act as SWIM-compliant subsystems. Why? On the left side, you can see more or less the current situation, which is ruled in the air traffic management community by a lot of one-to-one interfaces with proprietary data protocols, formats, dependent on the operating system, solutions only depending on one programming language or whatever. And the aspired status is that all the information is shared via solid, all communicating parties shared base, a kind of, you can regard it as a kind of enterprise, big enterprise service bus. And what is it, SWIM? How it is built up? You can see this red box. This is the SWIM scope. On the very down level you have the network connectivity, then you have the infrastructure referring message COM protocols. The next layer are the information exchange models, and there are three standards in the air traffic management community: AXM, FIXM, and WXXM. AXM is the Aeronautical Information Exchange Model. It refers to all the stuff for the aircrafts if they are on ground. Flight information exchange model, FIXM, more refers to what is the aircraft representing in the air, and the weather exchange model, WXM, it refers to weather. Then you have the specifications for the exchange, so the information exchange services, and on top you have the consuming applications, serving and consuming applications. It's another picture just to show SWIM is ruled by standards. You will see it some slides next, that it really it is a map where you can depict standards. It is based on standards, so it is a loose coupling, it's a methodology or framework for loose coupling systems, so that you are independent from operating systems, independent from programming languages. So SWIM what? Now there are some technical profiles. These technical profiles refer to three areas of information. Yellow is more for non-critical information, for example for flight planning and some stuff where you can afford some mistakes. Blue is for more critical information, so if you really communicate trajectories where you have to rely on. And purple is air-ground info exchange, so this is where you really want to have information, changed information, directly fed into the aircraft, into the cockpit. And just what does this mean, technical profile? Here you can see it, where you can, the different layers, transport, messaging, data representation, up to interface definition, and you can see there all these boxes refer to standards, and then you can depict standards. For example, the blue profile. What can you depict for the blue profile? For the transport, HTTP, HTTPS, DDSI, SOAP, data representation, XML. So these data exchange models are XML models. Interface management, the web service description language, and so on. So here you can depict standards, and then you are SWIM compliant. If you build up a web service depicting here and using AXM, FIXM, or WXXM exchange model. So what are the benefits? The benefits are that you have faster dedicated response possibilities, reduced implementation, operation, and enhancement costs. And it is requested. It is requested by FAA in the United States and by SESAR in Europe, and also on the Russian side and the Asian side. So SWIM is more or less something, a language the air traffic management community will speak over the world. So you have to be prepared for the future. And the challenge we are addressing with this is bringing in or integrating future global space traffic by taking into account the communication and data distribution about its possible debris footprint, so that if something happened, the aircraft under can evade, because there were some analysis that on average it lasts 10 minutes from the typical really dangerous area where something can happen, that it lasts 10 minutes for the debris coming down to the upper airspace for the normal air traffic. So in 10 minutes you can evade if you are informed immediately. So in our solution, our prototype solution is this called Space Re-entry Hazard Area Server. It just it gets in FIXM data for the spacecraft. Where is it? ID, lat long, altitude, heading, and path velocity. And for each message in it gives out a hazard zone polygon. A hazard zone polygon compliant to AXM as a temporary flight restriction airspace. So that this temporary flight restriction airspace in AXM format can be read by standard controller devices, controller assisting tools, so that it can be directly fed in the controller working position for the aerodrome airspace control. And we built our solution on what? Make an educated guess, Pickle. So we used the Tcl web server package, web services for Tcl package, TLS for the transcription, for using HTTPS, the RPC bar for the complex data type definitions, Tcl for enhancing the performance, and base X client Tcl, where we used some as a base X database server for our for the representation of the hazard model. So this is the solution structures of the sourcing. It's just, it was on my side a kind of spaghetti approach, but it worked. So just C coding, zone calculation, space hazard service, defined service, and the server. So defined service where we can add future services, so that we have this kind of tree structure. So what is it, and what were our solution or results for our first prototype tests? On the left side you can see our prototype, and that it communicates via this SWIM, and we tested it with our SWIM compliant clients. On the right side you see what we did in cooperation with Embry-Riddle Technical University, or Aerospace University. We exchanged our data, but we had to transfer because FAA SWIM is a little bit different than the European SWIM. You have to fed your SWIM answer through dedicated intermediate services. So there were some translation between, but at the end we succeeded. It worked, and the use case was they fed in the lap long altitude and velocity of a simulated spaceplane, and we gave back the preceding debris zone, and they were able to distribute it to a consumer electronic flight back display. Electronic flight back display means these are devices in the cockpit for planning or further information purposes, so that a pilot was able to see, there is a fluctuating zone coming in, and I am in that zone. So a direct information that a pilot may have to evade. Just an excerpt about what we did with the Tcl, so it's an example of the calculation heading procedure in Tcl. It's straightforward and
lots of trick.
Yeah. What you can see, what was the performance improvement? The left side, pure Tcl, in the right side, the calculate heading and the calculate hazard zone procedures in Tcl, performing in this on-the-fly C compiler. And next slide you can see the reaction times. These are the reaction times between input of message and reply, sending out reply, and it is nearly independent for 100 connected clients. So these reaction times did not fluctuate very large, but anyhow, so this might be sufficient for small or medium-sized use cases where you have up to 100 connected clients. But for the future, where you have thousands of clients anyhow, we prepared a kind of SWIM asset connector proxy also in Tcl, where we have, where it spreads up the requests to different servers on the right side. So the outlook, what is the next in our swimming TCL or swimming. We would like to develop a module called ZAC Swim. So it is between the enterprise service bus where the requests come from and where the requests go to, and it's a big data river, big data lake solution where what we plan to do is to classify, to have a machine learning algorithm which learns these swim requests for our service based on correct SOAP request messages and corrupted ones based on the header input or header content, the reaction time, the input time, and so on, and that we really can classify based on this with a machine learning approach if a request is not a normal request but is an attack to the system. So it's something for the security. And this is what we plan to do, that we would like to do it with Kafka and the MongoDB. It is not fixed yet, but it was our first approach, first idea, and so make an educated guess. It is developed in Tcl'2018. We plan to develop it in Tcl'2018, the Kafka TCL package, to use it or to have more, have a look in. And what we plan to do, or maybe there is also some work to use for the machine learning TensorFlow and to use the C++ RP inside Cree TCL. So this is our idea of how we can approach this. Yeah. Thank you very much for your attention. Are there any questions?
Where do you get the information on flights that are coming into the atmosphere? And for example, the satellites sort of break up in orbit. Where are you getting that? Air Force Space Command? Where are you getting
The input will come from future spaceplane or aerospace plane operations center. They will provide this information via Sublink, and we assume that such a way will exist.
So is FlightAware going to start tracking space stuff?
Yeah.
Tracking from space.
Tracking space, yeah.
Is Tcl'2018 scaling up what you need to do, or are you guys trying to look for something a little more modern?
Well, it fits to our approach, but you're referring to the version of the 1.2 or what we just.
Well, we're on 3.5 right now.
Yeah.
But I ran into a wall because it just doesn't play well with all the new stuff that went in 8.6 as far as coroutines and Tcl'20. So
Yeah.
I'll be presenting the successor to it.
Yeah, you are right. We have to be aware that we have to adapt to the actual versions, especially. But Swim still works based on 1.1 and 1.2. So we are still aligned with that. But you are right. When Swim proceeds requesting the newer versions, we have to find a solution for that. But then we can look in the package and see what we can do with it, or the package is further developed by the community and we can benefit from it. Yeah.
So you mentioned machine learning components. So I was wondering if you have experimented with any machine learning algorithms, and then what would be the precision recall, because accuracy will be important, and perhaps before investing further in development, you should have some idea about the accuracy.
Yes, that's right. Some colleagues of mine, they are more in this machine learning team, and they said maybe we can achieve an accuracy about 90% to identify attacks. And so this is this is a value we think it is worth to go further on, about the 90%. Some others said you will not go over 70, but other experts said try it. You can achieve over 90 with this approach. So if you have further questions outside from this room, do not hesitate to contact me. The email address is on the site, and we are always open and for questions, and always appreciate maybe some ideas, or if someone says, with that approach, I don't think you're on the right side, better try another one. We always appreciate if someone comes with a proposal or a consultation. Thank you very much.